Okay, ladies and gentlemen, this is the Algebra 1 final 6 weeks cumulative exam. In the first section, we are asked to identify the center and radius of a circle given its equation and then graph it. So that's what we'll do. For these two problems, because it's multiple choice, I'm going to need more space to work out the answer. So I'm going to move this piece of paper away and then rewrite this equation for number 1, and then we'll get into it. The first equation number 1, we are given x squared plus y squared minus 2x minus 6y plus 1 equals 0. Okay, so from this mess of an equation, we are supposed to somehow determine what the center and radius of a circle is. Just to review, in case anyone watching this video is not familiar with the terminology. If I have a compass, okay, this is a Statler compass. It's a very nice aluminum body compass. Put a pencil in it, it can draw beautiful circles. So I will attempt to draw a circle that you can see because the camera doesn't pick up the pencil very well. Okay. If I draw a circle with this compass, the distance between the compass point and the tip of the pencil is the radius of the circle. You see that? So the two principal characteristics of a circle are its center point, which comes along with a coordinate set x comma y, and then that distance from the center of the circle to the edge or perimeter of the circle, that distance is called the radius. Okay, and that's that distance that we measured with the compass. It's the distance between the tip of the compass that's at the center of the circle to the tip of the pencil at the edge of the circle. So those are the two things we're trying to find. Back to the equation. What do we do with this? Well, we're trying to get this equation into a different form that will give us the information. The first step to accomplishing this goal is to look through the equation and see if I have any numbers by themselves. I see one right here, plus 1. I need to move that to the other side of the equation. And to do so, I have to subtract 1 from both sides. And you would do this for any number that's just sitting by itself that doesn't come with a letter. Okay? Just for terminology purposes, these numbers that are by themselves are called constants. C-O-N-S-T-A-N-T. Constant. Okay, that means they don't change. They're constant. Okay? The ones that come with letters are called coefficients. And the reason those numbers are not called constants, they're called coefficients, is because when you plug in values for x and y, then the product of the number that's with the letter will change. So if I plug in, if all I have is negative 6y, and I plug in 1, then the resulting product is negative 6. If I plug in -1 for y, the resulting product is +6. If I plug in +2 for y, the resulting product is -12. You see, that changes. So that's the difference between numbers that are by themselves, which don't change. It doesn't matter what I plug into this equation. This number 1 is always going to be 1. I move it over to the right side, it's always going to be -1. You see how it doesn't change based on what I plug in for y? So just a terminological distinction that's worth noting. Now we're ready to rock and roll. What we have to do is group together our x terms and our y terms. So the way we do that is actually quite important. What we look for is the highest exponent that's associated with an x variable. And in this case, it's the squared. So we call this degree 2, the squared term, x squared, x to the second power. And we're going to write that first, x squared. And now what I'm looking for are any other powers or any other variables that are x. And so I find -2x. -2x. Again, more terminology. This is called the quadratic term because it's squared. And this is called the linear term because its exponent is 1. Just more terminology, as not particularly relevant to what we're doing. So we've grouped those together. Now we're going to intentionally leave a little space right here because we're going to write something here later. And then I'm going to put a plus sign. And now I'm looking for my y terms, and I'm seeking that higher order term. So this is the second order, 2, y squared. Y squared goes first. Okay, there's the quadratic term for y. These quadratic terms are what give the circle its curve. Otherwise, it would be straight line. Now I'm looking for anything else that's got a y. I see -6y. That's the linear term associated with y. And so I put -6y. And then I leave a space. And then I put an equal sign. And then bring down that -1 right here. Okay? Now, what we're going to do is put parentheses just like this. So to the left of x squared and just to the left of the plus sign. Then to the left of y squared and to the left of the equal sign, we'll close those parentheses. Now we're going to complete the square. And that all sounds very complicated, but it really isn't. All you have to do when you get the equation in this form, and there are no numbers in front of the x squared or the y squared, the equation didn't come with any. In cases where there are numbers in front of those two variables right there, you would need to, they'll be the same number. It could be 2, 3, 4, whatever. You'll just divide each term of the equation by that, what's called leading coefficient. And then once you get x squared and y squared where there's no leading coefficient at all, not even a negative sign, you are ready to complete the square. And so to complete the square is actually quite a straightforward process. Over here in the left margin of the page, we will create a little side work area, and we're going to do a small mathematical operation on the linear x coefficient and the linear y coefficient. We'll start with the linear x coefficient of -2. We will divide -2 in half. So -2 divided by 2, and that equals -1. I will then square that term right there, -1 squared. Now anything squared is positive. So -1 times -1, or -1 squared, equals 1. All right? So what I did there is I took the middle coefficient and I divided it by 2. And then I squared the result. So divide the middle term by 2 and square the result. Divide the middle term by 2 and square the result. Another way of saying that is square half the middle coefficient. Another way of saying that is square half the linear coefficient. Linear because it's with x raised to the first power. The linear term. There's the quadratic term. There's the linear term. We take the linear coefficient of x, we divide it by 2, and then we square the result. And that's what we get. That 1 right there, that positive 1. I now take that positive 1 and add it to complete the square. And now you see I have a completed quadratic equation, x squared minus 2x plus 1. Now because I added 1 to the left side of the whole equation, I have to keep my equation in balance by adding 1 to the right side of my equation. See, now my equation's in balance. Now we'll do the same thing to the y term. So I look for the linear coefficient of y, which is -6. That's the middle term. I take -6 and divide it by 2, and I see what that equals. -6 divided by 2 is -3. I then put parentheses around it and put an exponent of 2 to square half the linear coefficient of y. So I took the linear coefficient of y, which was -6. I divided it by 2. I saw that it equals -3, and then I squared the result. When you take -3 and square it, -3 times -3 equals +9. I will now add 9 to the y expression, completing the square to make another quadratic in terms of y. Now I have y squared minus 6y plus 9. Because I added 9 to the left side of the equation, I have to keep the equation in balance by going over to the right side of the equation and adding 9. Okay? So, over in our side work area, we can clean this up. -1 plus 1 plus 9 equals, well, math problem. -1 plus 1 is 0. 0 plus 9 is 9. So when I get back to the right side of the equation, I'll rewrite this as just 9. Now, it's time for us to recognize something important about completing the square. These quadratic expressions are special cases. They can be rewritten as either the sum or the difference of two squares. And whether you're going to write the sum or whether you're going to write the difference all depends on what's inside this little parentheses right here. So the key is if the linear coefficient is negative, you're going to be writing the difference of two squares. If the linear coefficient is positive, you'll be writing the sum of two squares. Here, in both of our x and y quadratics, we see that the linear coefficient is negative. So we're going to be writing two different expressions that are the difference of two squares. And so now that's what we'll do. So I created like a little template. All I'm doing is rewriting these two quadratic expressions in a simpler way. exploiting the fact that they can be written in this unique form called the difference of two squares. So here's what I'm going to do. This will have an x and this will have a y. I know that I'm writing the difference of two squares. So put minus, and the question is, what do I put right there? Well, it's the difference of two squares. So what I'm looking to do is put that number right there, 1, half the linear coefficient. So negative 2 divided by 2 is negative 1. So I've already written the negative symbol, and now I just write 1. And now I square that. So x minus 1 squared, I claim, is equal to x squared minus 2x plus 1. If you don't believe me, you can check. You take x minus 1 times x minus 1 and see what you get. And we'll use the FOIL method, F-O-I-L, first, outer, inner, last, to see what we get when we expand this binomial. This is a binomial. There are two terms here. This is a trinomial. There are three terms here. We've turned a trinomial into a binomial, and now we're going to expand that binomial by using FOIL. So x times x, first term, is x squared. Outer, x times negative 1, negative 1x. Inner, negative 1 times x, negative 1x. Last, negative 1 times negative 1, positive 1, and that's it. And now what we do is simplify by combining like terms. I have x squared, and then negative 1x minus 1x gives me minus 2x plus 1. And so I've demonstrated now that you can go from x minus 1 times x minus 1, which is just x minus 1 squared, and I can get back to my original quadratic expression. My trinomial can be found by expanding my binomial. Now I'll do the same thing for the y value. So here I look inside and I see negative 3. And basically, you just write that, y minus 3. And then you square that. And you see now that we have two different difference of squares. This is the difference of two squares. This is the difference of two squares. We have two sets of them, one in terms of x, one in terms of y. Over to the right, I will write down my sum. Negative 1 plus 1 plus 9 equals 9. I am now ready to identify the center of this circle. The center of this circle, remember from our picture that we said there would be an x and a y. The center of the circle is located at the following coordinates. You look at x minus 1, all right? And the x value that is at the center is 1. Now, the question is, how do you know that? Some people say, just cover up x minus and put whatever that number is. You know, another way to look at this is to say, well, what exactly does x equal? X minus 1 set equal to 0, then solve for x. You add 1 to both sides, and you get x equals 1. So x is 1. When you try to jump ahead a little bit, you start to see that when you have a negative 3 right here, you know that when you set y minus 3 equal to 0 and solve for y, you will turn that negative 3 into a positive 3. So if you got y minus 3 equals 0, I want to know what y is. I add 3 to both sides, and I get y equals positive 3. So 1, 3. Now, what is the radius? the radius is equal to the square root of the right side of the equation. So I'll take the square root of 9. And in this case, I'm only interested in the positive result. If we take the square root of 9, that equals plus or minus 3. As I said, I'm only interested in the positive result because we're dealing with a distance. So this has to be a positive number. So when I take the square root of 9, I'm only interested in that positive result. So that means that my radius equals 3. Okay? Some people have asked a very good question, which is why? Why is the radius equal to 3? And because I was trying to show this process in a quick way the first time through when I was teaching it, I didn't show kind of the mechanics under the hood. The reason that we have to take the square root of the right side is because we actually took the square root of the left side before we did that. Okay? So if you were to take the square root of the left side, you would have to then do the same thing to the right side. You'd have to take the square root of the right side. And when you take the square root of the left side, these squares disappear and you're just left with y minus 1 or x minus 1 and y minus 3. So that's where we get down to where we can just solve for x and solve for y. But that is why that square root comes into play, because I'm trying to get rid of that squared term. Okay? So now that I know that the center is at 1, 3, and that the radius is at 3, I will now graph this circle. So for this, we'll try to make an accurate graph, and I think I'll make every ½ inch of this ruler a point on that graph. Okay, almost drawn off the page. Okay, so this is the y-axis, and here we'll draw the x-axis. Make sure you're drawing a straight line. Now we'll demarcate our lines every ½ inch. So this is 1, 2, 3. Okay, this is 1, 2, 3. And then over here, this will be 1, 2, 3. 1, 2, 3. Okay, here's the origin point right here. And now I can actually draw my circle. First, I need to plot the center of the circle. The center of my circle is at 1, 3. So I go over 1 on the x-axis and then up 3 on the y-axis. And I've got my center right there. Okay, now I'm going to draw the circle. And to draw the circle, I'm going to change out the pencil, see if I can fit a pen in here so it shows up clearly. To draw the circle, get my pen seated in here firmly. I just have to take my compass and expand out that radius to be 3 according to my graph. So if I put the point at 0, 0, okay, I can actually measure out, according to my graph, what would 3 be within within the context of this graph. 3 units is right there. You see, I've made myself a little ruler on the page. And so that's now distance 3. And this circle is actually going to cross through some of my work, but that doesn't matter. So the circle will actually look like this. So I put my compass point right at the center of the circle at 1, 3, and then I make a circle with a radius of 3 that articulates all the way around the center point. Okay, so that is how you draw the circle once you find its center and radius. It probably won't look like that in the answer choices, but it will still have the same characteristics. This will be 1, 3, and the radius of the circle, this distance from the center to the perimeter, will be r equals 3. So let's go to our answer choices and see if that is in fact what we find. Do we find an answer choice with that information? Okay, and that's your job. Your job is to go to the answer choices and see if there is an answer choice that has a radius of 3, that graphs a circle with a radius of 3 and a center at 1, 3. Okay? So I'll leave that up to you to do. And now for problem number 2, we just have another circle equation. We're going to move through this problem, number 2, without all of the elaboration. We'll just move through it kind of algorithmically, as quickly as possible. So, we've got number 2. And the equation that they give us is x squared plus y squared plus 4y equals 0. Okay? In many ways, this equation is simpler than the one we just did because there are fewer terms. There is no term that we have to move to the other side. And if we look through our system or our equation here, our expression on the left side, I do not have a corresponding linear term for x. So we will group x by itself, x squared by itself right here, x squared, and I'll leave a space. And then I will put a plus sign. And then I will write y squared. And then find that I have 4y plus 4y. And then I will leave a space. Okay, put equals 0. Again, we will put parentheses around our x expression and parentheses around our y expression. Okay, what's going on here? Well, this may be why this is number 2 and not number 1, because you have to think about what a standard form equation of a quadratic actually looks like. So a standard form equation quadratic is ax squared plus bx plus c. Okay? And we know what a is. A is 1. So, see, there's a 1 in front of that x squared. So it's 1x squared. So let me ask you a question. What would b have to be in order for this linear term to disappear entirely? let me rephrase that. What times x equals 0? The answer is 0. So it's plus 0 x plus c. Okay, and we're really only interested in these first two terms. So the linear coefficient is 0. The middle term is 0x, and it disappears whenever you try to write it. It's like an elementary particle that's produced in a particle accelerator. The moment it's created, it disappears. So the moment you write down 0 times x, it immediately evaluates to 0, and you lose the x. So that's why it's not written here, but we can write it plus 0x. Okay? When we take half the coefficient and square it, we'll still end up with 0, but we'll get to that. All right, so now over in our left margin, we'll do our side work. First for x, I will take half the linear coefficient, half the middle term, 0 divided by 2, and I'll see what that equals. 0 divided by 2 equals 0, and then I will square 0. 0 squared is 0, and so I will write plus 0 right there. For the y term, we have a little bit more interesting work to do. We have positive 4y, so the linear coefficient is positive 4. I'll take half the middle term, or half the linear coefficient of 4, 4 divided by 2, and that equals 2. And then I will square the result. 2 squared is 4. So I will add 4 over here. Now, to keep my equation in balance, I will add 0 and 4 to the right side of the equation. Some people doing this are shaking their heads and saying, all of this seems a little bit pointless. Well, okay, we'll see, right? It's a question that came up from a very bright student that was kind of wondering what to do in this situation, and I want to make sure that I'm being extremely thorough. So I'm now going to write either the sum or the difference of two squares for both x and y. For x, I write x, and we'll go with the sum of two squares here. X plus whatever is inside here. It says 0, so x plus 0 squared plus, open parentheses, y, and now I've got this term here is positive, so I'll put plus 2. So I see now that I've got the sum of two squares. And what does that equal? It equals 0 plus 0 plus 4, which is just 4. Okay? And now, we can say what the center and radius of the circle is. The center of the circle is located at 0, 2. I'm sorry, the center of the circle is located. I've just made the mistake I was trying to teach you not to make. So in order to find out what I put right here for the center of my circle, I have to actually solve these little equations here. So first, I'll solve for x. X plus 0 equals 0. And I'll solve for x. Minus 0 minus 0. X equals minus 0 is just 0. So x equals 0. So this is 0. Now, please don't make the mistake I just made and quickly, without even thinking for half a second, just write down that number. For the y value, we actually have to put y plus 2 equals 0. And we subtract 2 from both sides, and we get y equals negative 2. So the y value of the center of the circle is negative 2. So there's a little alligator there, right? Now, what is the radius? The radius is the square root of the right side. Remember, we're taking the square root of both sides in reality. We'll take the radius as the square root of the right side. So we'll take the square root of 4. And remember, I'm only looking for the positive root. So the positive root is 2. Because if you take the square root of 4, you get plus or minus 2. But because we're trying to find the distance, the radius, we just keep that positive root of 2. And now it's time to graph, the most fun part of these problems. Okay. Here I'm putting my x-axis up pretty high because I know that I have a negative y-intercept at negative 2. So I put my x-axis way up here so that when I graph this thing, it will fit on the page. So this is y and this is x, 0. And now I'll use my ruler half-inch markers to mark off some distances, try to keep it accurate. So I'll put that there, and I'll mark off every half-inch. So we'll go up 1 on the y-axis, and then down 1, 2, 3, 4, 5. So this is negative 1, negative 2, negative 3, negative 4, negative 5. And over here on the x-axis, I'll mark off positive 1, 2, 3. This is 1, 2, 3. So where does our center live? Our center lives at 0, negative 2. So I go to the origin point, and I don't move anywhere because I'm at my x-coordinate, which is 0. And now I go down 2. So this is the center of the circle right here. And now I need to use my compass to determine the appropriate radius. We know the radius is 2, but I've got to actually measure out what that looks like on the physical page using the scale that we invented with our ruler when we drew the graph. So my current radius is set to 3, but I need the radius to be 2. So what you do is you turn this little knob right here, okay, and it changes the radius. See that? You can just also pull it, but that isn't as a fine tuning method. And what you're going to do is measure off a distance of 2. Okay, so that looks like 2. And as you get up into geometry, algebra 2, pre-calculus, and calculus, precision matters. So it is worth it to take your time. Now plant your pointy end of your compass right there at the center of the circle. And we're now going to circumambulate or walk around the center of that circle with our compass. Okay, so there it is. There's our circle with a center at 0, -2 and a radius of 2. Just finish labeling it. 0, -2 and radius r equals 2. The question is, do we see a multiple choice answer that gives us that information? And I will, of course, leave that up to your, I'll leave that task in your very capable hands. Okay, so that was number 2. Number 3 asks us to find the inverse of the function, then graph both the function and its inverse, and find where they intersect, and the intersection point of the two lines, if they ever intersect, that intersection point is the solution to the system of equations. Now, I told you to indicate the solution and the number of solutions. So just because your different answer choices only give you equations and graphs, what you're supposed to produce is a graph, an equation of the inverse, and the solution to that system of equations consisting of the original function and its inverse. And then you have to tell me how many solutions exist. So it's easier, honestly, to not look at the answer choices and just do it yourself than to try to interpret these answer choices. That's why I hate multiple choice tests, because your eyes are drawn down to the answers when you really don't need to look at them at all. Just take what they give you. G of x equals x minus 2. And that's what we're going to be working with. So you throw away the test here for a second. And this is going to be number 3. Number 3 says G of x equals x minus 2. Okay, so how do we find the inverse of this function? Well, the very first thing we do is whatever this is, g of x, f of x, r of n, m of p, it doesn't matter. Just drop that function notation for a moment. Just drop it and write y. This isn't strictly required, but it's much, much easier. So write y and then put equals x minus 2. And now comes the part that people find both weird and difficult to remember, but it's actually extremely simple. So we come up with this little motto or mantra or chant, and that is something that is, as often as I say, don't memorize anything, this is something that would help to remember because it's so easy to forget. So that, like, what do I do once I drop the g of x and write y equals x minus 2? I swap x and y, and then I solve for y. This is the thing you got to remember. Swap x and y and solve for y. You should say it in your head 1,000 times. When I was a kid, we didn't have phones that stored numbers. So when your friend told you their number, you would write it down and then you would say it to yourself 1,000 times over and over and over again so you could remember. And then, of course, when you picked up the phone, the only way to contact that person was to dial it. So over the course of years of calling your buddies, you would end up remembering dozens or even 100 or so phone numbers. To this day, I remember the home phone number of all my childhood friends. It's kind of weird, right? Because now you might even put your parents' phone number in your smartphone, and if I, as your teacher, ask you, what's your mom's phone number? I got to call your mom to talk about the parent-teacher conference. A lot of times students tell me they don't remember. They don't know the number, so they got to look in their phone to tell me what it is. And that's quite shocking. But quite honestly, my own brother, he's got a new phone number. He changed the number after like 12 years of having the same number. I have no idea what it is. I took the new number and I dropped it into the contact list and I just stored it. The reason I went off on that little digression about phone numbers is because we don't tend to like to remember things anymore. But this is one of those things where you've got to remember to do this. So when I was saying about repeating the phone number 1,000 times, I used to repeat my friends' phone numbers over and over again until you got it, until you memorized it. And we don't do that anymore. But here, it might pay to just say this 1,000 times, just as you're getting ready in the morning. You're getting ready for bed. Some people say count sheep or count down from 100 to go to sleep. Just say this over and over again. That'll put you right to sleep. Trust me. I've got students that sleep every day in my class. I know this works. It's better than a sedative. Just say it over and over again. Swap x and y and solve for y. Swap x and y and solve for y. And repeat 1,000 times. Okay, so let's actually do that. Let's swap x and y, then solve for y. And kind of do so on autopilot. Just do it. So if y equals x minus 2, then x equals y minus 2. And now solve for y. So I'm going to get y by itself by adding 2 to both sides. And now I have x plus 2 equals y. There's some fancy property in mathematics that says that I can rewrite this as y equals x plus 2. I can never remember the name of it, but as long as you know that you can take x plus 2 equals y and rewrite it as y equals x plus 2, you're good, bro. And now we're going to introduce this notation called the inverse notation. And as I've said before in class, this is terrible notation. But it is the exponent negative 1. And the way you read that, now that you've written that there, is y inverse equals x plus 2. If you want to put this y back into function term, you'll write g negative 1 exponent, open parentheses, x. So g inverse of x equals x plus 2. And now you've done it. Okay? So now all we have to do is graph the two and see if they intersect, and if so, how many times and where, and then we will know our answer. So we found the inverse function, and now we just have to graph both of them. This is where it really, really does pay to have some colored pencils laying around. So I will use, it's going to show up on camera. I will use this green colored pencil, and I will use this dark red colored pencil, kind of a Christmas in July thing. And we'll graph those two lines. I'll graph the original equation in green. I'll indicate that by drawing a little green dot. It's coming out more hazel or washed out, like autumn leaves, sage colored. And then I'll put this red dot that's coming out more like maroon or purple or cyan right there, just so you know what I'm doing. The green function, the green color will be the original function. The red color will be the inverse function. Okay, let's draw a graph. Okay. And we'll put little arrowheads on our y-axis. And then we'll put in our x-axis. So many students hate taking their time and drawing these graphs out. Now, some love it. But I'll tell you, it's one of those things where if you just embrace the fact that you have to do it, it becomes easier. And if you take pride in your work and you take pride in making it beautiful, okay, think about Steve Jobs and how he was obsessive about the aesthetic, physical beauty of the iPhone, right? Maybe you hate iPhones or you hate Apple products, okay? But you have to appreciate the aesthetic beauty of the thing. Take your time to make things pretty, okay? Keep your lines straight, make your letters pretty. You'll just feel better about your work. You'll feel like you accomplished something important, and you of course you are, but when you do it rushed and you don't take pride in what you're doing, then it all just feels like a bunch of mundane, boring torture that I'm inflicting upon you. Which if that's how you view it, well, first of all, I'm very sorry. But second, I can tell you this: unless you can contact your state legislator and have them drop the requirement that you learn mathematics, him or her, drop the requirement that you learn mathematics in high school, then, brother or sister, whoever you are, you're going to be doing this kind of stuff for the next 3 or 4 years of your life, depending on what grade you're in. So this is one of those situations where if you can't beat them, join them. You ever heard that expression? So, I used to hate doing this stuff. I just want to let you know that. I hated it. It felt like pulling teeth. I know that's what my mom would have said it felt like. Trying to get me to do this homework felt like pulling teeth. And believe me, she would know what she's talking about when she says that. But once I started to realize I could make it pretty, make it artistic, then that side of my personality was engaged. It's like, you know what? I don't want to do the math, but I do want to make it look nice. All right. Okay. So now we'll use before we get to the color, we'll kind of plot in what we need. Now, when I start graphing the original function, I've got to locate two things: the slope and the y-intercept. Now, the slope is actually hiding in front of the x. It's just 1. So the rise will be 1, and the run will be 1. So up 1 over 1, up 1 over 1, like a staircase. Up 1 over 1, up 1 over 1. But I got to start at the y-intercept. What's the y-intercept of this linear function? Your eyes should be drawn right here. So mx plus b, where b is the y-intercept, -2 is the y-intercept. So go down to -2, and I'll put a little dot. And now what we'll do is we'll go up 1 over 1, right there. Now that I have two lines, I'll use my green pencil to connect those two lines, and this will be my original function. Okay, cap on that. And to be good math citizens, we want to identify our functions to the rest of the world. So I will write over here, g of x equals x minus 2. Okay, now let's graph in our other function, the inverse function. Now I've got to identify the slope and the y-intercept. The slope is 1 and the y-intercept is positive 2. So we'll go over to 0, positive 0, 2, put a dot, and now look, I got a slope of 1. So I'm going to go up 1 over 1. Go up 1, starting at that y-intercept, up 1 over 1. Put a little dot right there. And now I'll use my red colored pencil or cyan colored pencil, whatever, and I'll draw in this second line. Try to make it perfect here. Okay, there's my second line. And this is the inverse function g inverse x equals x plus 2. Okay, so now we're looking for the intersection point. I'm looking for the intersection point, and I don't find it. These are parallel lines, aren't they? And we could have known that earlier by recognizing that they had the same slope. Remember, parallel lines, I never remember if there's two R's or two L's. I always just roll the dice on it. Parallel lines have the same slope. We learned this in the first semester of Algebra 1. What fact do I know about parallel lines in terms of how many solutions exist to the system of linear equations consisting of two parallel lines? What I know is that there are no solutions. If I did not remember that, I could have taken the original function, x minus 2, and set it equal to the inverse function, x plus 2, and then tried to solve for x, right? So watch what happens when I do that. You come up with a mathematical contradiction. So now I'll subtract x from both sides. X minus x is 0, minus 2 equals 2. And now I'm left with the mathematical contradiction that negative 2 equals positive 2. And those do not equal one another. So negative 2 does not equal positive 2. Therefore, this system has no solutions. Okay? So that was solving a system of equation by substitution. The system has no solutions. So what we're looking for in our answer choices is something that graphs two parallel lines with the original function being x minus 2 and the inverse function being x plus 2. And then you are going to write, first you're going to graph the lines, and then you will write this. Now I hope if you are actually doing this for test corrections, you are required to do this, but I hope you're doing this work. You know, find a ruler. Even if you don't have a ruler, you can create, with just a piece of paper, you can create a little homemade ruler, a notebook, index card, or credit card even. You can create a little ruler that you're drawing these pretty graphs, putting some love, TLC, tender love and loving care into it, and mapping this all out. Now, if you're doing this for test corrections and you're, upset with me that it's taking so long, then look, this is the, here's the proposition. Don't take the test corrections then. This is what's on offer if you didn't learn the material in class and you want me to give you the answer, then you are required to watch this video and write down everything you see me write down. Okay? And I've grown somewhat unconcerned with whether this is an inconvenience to you or not, because listen, not to put too fine a point on it, but I'm not required to offer these solutions at all. And certainly on weeknights and weekends in a busy work schedule at a school, I don't want to sit here and make long videos, but I do want you to understand what's going on. And so it's like, well, you didn't learn it in class, otherwise you wouldn't need to do test corrections. So it's one of those like, well, as one of my good students says, it is what it is. And so what I want you to do is just copy all this down and then find the answer on your test. If you notice some hesitation on my part to just show the test, it's because I've learned over the course of the year that what people do is they scan through the video until they see me circle the correct multiple choice answer, and then they do that. So I'm not doing that. If you're not watching the video and actively participating, then you will really have a tough time figuring out what the correct answer is, because I never quite get around to circling it on the test. All right? That was number 3. Let's move on to number 4. Okay, number 4. I don't even need to show the test document. Number 4. For number 4, you are given f of x equals 5x over 2. So you're given f of x equals 5x over 2. And what you are asked to do is find the inverse of this function and graph both functions, see where they intersect, determine how many solutions exist, if any exist, and list those solutions. So we're starting here, and what we're first going to do is drop the f of x notation and write y equals, and we'll write 5x over 2. And now I follow my little script. Swap x and y and solve for y. Okay, so I'll swap x and y. If y equals 5x over 2, then x equals 5y over 2. And now I solve for y. So y is buried right now. If you say this out loud, it will help you understand what you have to do. 5 times y divided by 2. So let's say it another way. If I'm y and I want to be alone, what do I need to do? First, I've got to rid myself of this 2 in the denominator, and then I've got to rid myself of the 5. So how would I rid myself of the 2 in the denominator? Well, because 5y is divided by 2, I can multiply by 2 as long as I keep the equation in balance by doing the same thing on both sides, I'm fine. The wonderful thing about multiplying by 2 on the right side is it cancels out the 2's. And now I'm left with 2x equals 5y. Remember, I'm solving for y. So now I have 5 times y, and I need to get y by itself. So I divide everything by 5. Okay, so now these cancel, and I'm left with 2x over 5 equals y. Perfect. And remember that there is that property of mathematics, the equivalence principle or something, that says I can rewrite this y equals 2x over 5. Okay, And remember, we're going to use that inverse notation. So I'll put this little -1 here. And so I've got y inverse equals 2x over 5. Now, here's the thing we need to think about right now. We have to graph these two things. So it's difficult to think, how am I going to graph this weird looking expression, 5x over 2, and this one, 2x over 5? These are not in y equals mx plus b form. What we've got to do is disentangle the fraction 2/5 from the x. All right, I need to pull it apart. And so what I can do, I'll start with the original function 5x over 2. I need to realize that 5x over 2 is equal to 5 over 2 times x. So write this in a way that will make it easier for me to graph it by making the slope jump out, rise over run. Okay? Now you know what the rise and the run are. 5 is the rise, 2 is the run. Down here, do the same thing. Is equal to 2 over 5x. A couple of attention-paying students asked, what is the y-intercept? Well, if y equals mx plus b, this is m, that's x, and in reality it's plus b, which is 0. So plus 0 and plus 0. It's one of those things we just don't write because it seems superfluous or unnecessary. But if you're just learning how to do it, it can be extraordinarily helpful. Now we must graph. It has dawned. The time has come to graph. Let's graph. I'm going to draw my y-axis. And I'm going to label it y. And I'll draw my x-axis. Okay, and now I've got to create a little scale. Okay, so my scale needs to have some dimensions that will handle the parameters of these functions. So I know I've got a 5 somewhere in these functions. Here there's a 5, here there's a 5. So I've got to have at least a minimum of 5 markings on these axes. Let's make sure I can do that. We might have to change the little tool we've been using, because half inch spacing between the numbers will be too much. So now I think I'll use 1/4 inch spacing so I can fit at least 5 of them in there. So here I'll go up a 1/4 inch, put a little line, up another 1/4 inch. So that's 1, 2, 3, 4, 5, 6, 7. They're each spaced 1/4 inch apart. 1, 2, 3, 4, 5, 6, 7. And then on the x-axis, we'll do the same 1/4 inch spacing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Didn't need all those, but whatever. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and now we can graph. So first, let's get 2 different colors this time. We will use orange, and what's another color? Blue, orange and blue. Those look harmonious. If I use that green, I'd have the like fall colors. but we'll use orange and blue, whatever. And I'll make blue my original function, and I'll make orange my inverse function. Now, before I do that, I should probably turn this y back into f inverse x equals 2/5 x. Okay, that's the inverse form. Okay, so now that I've got my two functions, I'll graph the original function, which has a y-intercept at 0, and then it has a rise of 5 and a run of 2. So I go up 5 over 2. Up 1, 2, 3, 4, 5 over 2. Over 1 over 2. And you know, I was thinking about the boredom associated with watching these videos, and I thought, you know what? I completely understand. When I'm watching a math tutorial video, I do want to share some solidarity with the viewers who are just having to sit here and watch this. If that's what you're doing, then please stop, because I don't want you to watch this video. Okay? There is a caveat. I don't want you to watch this video. I want you to do what I'm doing. So I want you to be pausing this video constantly so you can catch up with what I'm doing. So you're more or less participating in the video along with me. If you're just sitting there watching, okay, you're probably dying of boredom. But if you're actually doing this along with me, then you might actually be trying to move ahead to get it going a little bit faster. So this was f of x equals 5 over 2x. Now we'll graph in the inverse function. F inverse x equals 2/5 x. My rise is 2, my run is 5, and my y-intercept is 0. So I start at 0, and I rise 2, and I run 5. So go up 2 over 5. Make sure I get this exactly right. Okay, so there's another point, and here's a point, and we'll connect them with the orange line. Yeah, don't just watch these videos, do the videos. I just want to share that when I watch a math video, if I'm tired and I'm not actually sitting up ready to work and I'm just trying to watch it, I become bored within seconds because I'm not doing anything. So if you're doing the video and you're not watching the video, then you're not bored. If you're just watching the video, just praying that I'm going to write the answer somewhere, tough luck. It's not going to happen. Okay. So now f inverse x equals 2 over 5x. Okay. And so these lines, thankfully, do cross, and they cross at the origin point, 0, 0. So this has one solution. And that solution is 0, 0. Okay. A very good student in the last period of the school day, a couple days ago, asked, how do you know that? Like, what if you didn't draw the graph? This is what she asked. She said, what if you didn't draw the graph? How would you know that it was 0, 0? Well, let's just do what we did before. Let's drop the f of x and f inverse x and just set 5/2 x equal to 2/5 x. Let's see what we get. If we put 5 over 2x equal to 2 over 5x, and solve for x, we'll find out what x equals. So I will try to get x by itself. I can start on either side, but I'll do that here. I have 2/5 times x, so if I want to get rid of the 2/5, I'll multiply by the reciprocal, 5/2. And I have to do the same thing on the other side. So I have to multiply by 5/2 on the left. Okay? Now on the right side, the wonderful thing is those cancel out, the 2's cancel out, and the 5's cancel out, leaving x by itself equal to 5 times 5 is 25 over 2. Over 2 times 2 is 4 times x. And now I want to divide out x. Okay? Or I want to divide out. I want to get x by itself. Keep saying divide out x. I want to get x by itself. So first I need to get the two x's on the same side of the equal sign. So I subtract x from both sides now. You know, and this isn't the only way to have done this, but it is in fact one way. So now I have 25/4 x minus x equals 0. And I'm on my way. I just have to find a common denominator between this coefficient and that coefficient, which is currently -1. And that common denominator is going to be 4. So I'll replace that 1 with 4/4. I have 25/4 x minus 4/4 x equals 0. And now I say, well, I've got the same variables, so I can in fact perform subtraction on these coefficients because these coefficients have common denominators. So I'm really just subtracting 4 from 25, and I get 21/4 x equals 0. And then I'm going to multiply both sides by the reciprocal of 21/4, which is 4/21. And on the left, those 4's cancel out and the 21's cancel out. And I'm left with, on the right, x equals 0 times 4/21. And 0 times 4/21 equals 0, so x equals 0. All that work to find out that x equals 0. Now we know the x term of our solution. To find out what the y term is, I have to plug in our x term of 0 into either of the equations. They'll work for both. I'll show you. F of 0 equals 5/2 times 0, and F inverse of 0 equals 2/5 times 0. And both of these, 5/2 times 0 is 0, and 2/5 times 0 is 0. They both evaluate out to 0. So, in other words, if x is 0, then y is also 0. According to this system, that's what comes out. So that's why our solution is 0, 0. Okay? And that was number 4. Number 5 gets really fun because we get to do polynomial division. Polynomial long division. It's always fun to do. 5, 6, 7, and 8 all involve polynomial long division. So, take number 5. I'm going to divide. I'm actually going to write this in the way that you will typically find it. Rather than using the word divide, I'm going to write this in the way that you'll see it when you get into Algebra 2 and pre-calculus. It won't say divide. It's not going to tell you what to do. It's going to say change to simplify. Simplify. And then they'll give you x cubed minus 13x squared plus 38x minus 18. And then they'll have a big fraction bar right here over x minus 9. And it will just be given just like that. Simplify. Ha ha ha. Right? Oh, no, it's evil, right? There's little horns coming off this word. Simplify. It's scary. Now that we know that in this case, I mean, simplify could mean many things. It could mean factor. It could mean reduce. In this case, it means divide. Okay? And we're going to divide x cubed minus 13x squared plus 38x minus 18 by x minus 9 using long polynomial division. And here's how that looks. We will now write the 4-term equation again. So this is a degree 3 equation, x cubed minus 13x squared plus 38x minus 18, all divided by, so this is why it helps to have a straight edge, all divided by x minus 9. Okay? Now here's how that looks. Here's the process you have to follow. I tell my students, cover up that term, the minus 9, and just look at the x. Okay? I have to ask myself the following question. What would I need to multiply by x to equal x cubed? Okay? You're looking at these two terms right here. X times what equals x cubed? And the answer is x squared. X to the first power times x to the second power equals, remember the product property of exponents, equals x to the 1 plus 2 power, which equals x cubed. Okay, so I have to multiply x times x squared to get x cubed. And where am I going to write that? I just come up with that, and I need to write it somewhere. I'll write it here, x squared. So I know that my quotient is going to be a quadratic because the highest degree term is squared. So it's going to be a quadratic. So I'm dividing a cubic by a binomial. See, cubic because the highest order exponent is 3. A cubic divided by a linear binomial, and the result is a quadratic. Interesting. Okay, now what? Now we multiply x squared times x, and we get x cubed. And I multiply x squared times negative 9, and I get negative 9x squared. Then we follow a new little motto, and that motto is something else to remember. Draw a line, change the signs. Okay, good to remember. Draw a line, change the signs. And that's what we're going to do here. We're going to draw a line and change the signs. So that becomes negative x cubed plus 9x squared. Now we stack add. Okay, then we stack add. And this is the process over and over and over. And the wonderful thing is x cubed minus x cubed is nothing, so it cancels. Some people don't like when you make the cancel, right? I just think it's fun to draw that line. And then negative 13x squared plus 9x squared is negative 4x squared. This first term should always get canceled. It should always go away. If it doesn't go away, check your work, because it should. Now, your mind should be begging you to do something. And what it's begging you to do is bring down the next term, plus 38x. All right? And so now we're back to our little game. What do I have to do to x to make it negative 4x squared? Well, I'd have to multiply it by negative 4x, right? Let's check that. So x to the first power times negative 4x to the first power equals, okay, coefficient of x is 1. 1 times negative 4 equals negative 4. And then x to the first times x to the first, apply the product property of exponents, and you get x squared. Okay, so negative 4x is what I needed to multiply by x to turn it into negative 4x squared. So where do I put that? I put it up here, minus 4x. So now I've found the quadratic term and the linear term. Now I'm just waiting to find that constant, that final number. But first, I have to multiply through. Negative 4x times x is negative 4x squared. And negative 4x times negative 9 equals positive 36x. Okay, and now I have to draw a line, change the signs. Draw a line and change the signs. Because I'm using pen, I've got to do a little editing magic with the liquid paper. So this becomes positive 4x squared minus 36x. The first terms cancel. And then I have positive 38x minus 36x, and I come out to positive 2x. And then I bring down minus 18. What do I have to multiply by x to get 2x? So x times what equals 2x? X times 2 equals 2x. So it's 2. Put a positive 2 up here. Okay? So that should be the quotient. We'll see if there's a remainder. First we'll multiply 2 times x, and that's 2x. And then we'll multiply 2 times negative 9, and that's negative 18. All right? And draw a line, change the signs. Okay? These cancel, and these cancel, leaving nothing. So your quotient has now been given to you. Okay? Number 6. Number 6, I wonder if we could use the same page here for number 6. Maybe. Okay, number 6. We're going to divide, in this one, 10p cubed plus 85p squared minus 44p plus 9. We're going to divide that by p plus 9. Okay? So what do I have to multiply by p to get 10p cubed? I have to multiply by 10p squared. So 10p squared is the first term. 10p squared times p equals 10p cubed. 10p squared times 9 equals positive 90p squared. Draw a line, change the signs. I have to change the signs. The first terms cancel, and the second terms add to negative 5p squared. Bring down the next term, negative 44p, and ask what times p equals negative 5p squared, and the answer is negative 5p. So put negative 5p. Negative 5p times p equals negative 5p squared. Negative 5p times 9 equals negative 45p. Draw a line, change the signs. These cancel, and you're left with p, 1p, which we just write as p. Bring down the 9. P times what equals p? 1. So p times 1 equals p, so put plus 1. 1 times p is p. 1 times 9 is positive 9. Draw a line and change the signs. Okay, and that is number 6. Let's do number 7 now. Number 7 asks us to divide b cubed plus 7b squared minus 13b minus 6 all by b minus 2. And cover up the negative 2. What times b equals b cubed? And that's b squared. B squared times b equals b cubed. B squared times negative 2 equals negative 2b squared. Draw a line, change the signs. Those cancel right there. And now I have 7 plus 2 equals 9b squared minus 13b. We bring down that minus 13b. Cover up the negative 2 and say what times b equals 9b squared? And that's 9b. So b squared plus 9b. 9b times b equals 9b squared. 9b times negative 2 equals negative 18b. Draw a line, change the signs. Negative 13b, okay, so these cancel. Negative 13b plus 18b equals 5b. Bring down the negative 6. What times b equals 5b? Positive 5. Put a plus 5 up here. 5 times b equals 5b. 5 times negative 2 equals negative 10. Draw a line, change the signs. These cancel, and you're left with negative 6 plus 10, which is positive 4. So we have a remainder in this problem. And so our answer is b squared. So I write the quotient, the whole part of the quotient. B squared plus 9b plus 5. And then I do exactly what I would do in any other long division problem. I always use this as the example. 23 divided by 2. 2 goes into 2 one time. 1 times 2 is 2. 2 minus 2 is 0. Bring down the 3. 2 goes into 3 one time. 1 times 2 is 2. 3 minus 2 is 1. So we have a remainder of 1. And so the answer is 11 and what? And this is actually something I guess students don't learn anymore. The remainder right here comes around and becomes the numerator of a fraction. Comes 1. And the divisor comes around and becomes the denominator of a fraction. So the answer is 11.5. You see how I did that? And so I'm going to do exactly that right now. But instead of 11 being kind of the whole number, part of this proper fraction, we're using a quadratic expression as the whole number, part of the proper fraction, if you will. And so now I've written that whole number. So this is in place of the 11 over here if you're trying to follow along. And now, so this 1 is going to come around and whatever is in the 1 position down here, this 4 is going to hook around and become the numerator of a fractional remainder. And what's going to go in the denominator is the divisor. Divisor is b minus 2. Now, since 4 is a positive number, we put plus right here. And this often confuses people. Maybe make it look a little bit better writing it like that. This often confuses people, but remember, you're doing the same thing right here. 23 divided by 2 is equal to 11 plus half, plus a half. And the answer is 11.5. So people say, well, are we multiplying this quadratic by this fraction? No, you're adding the two. So, you know, that's your quotient right there. And that's how you do those where they have a remainder. Okay, I think 8 also has a remainder. The remainders aren't bad. You just have to kind of remember a simple case and to know where to put the remainder and the divisor, and you'll get it. Okay, and now number 8, this is the last polynomial division problem. Number 8. We're asked to divide n to the 4th power minus n to the 3rd power minus 10 n squared plus 33 n minus 30. We're asked to divide all of that by n plus 4. Okay? So cover up the plus 4 and ask yourself, what times n equals n to the 4th power? And it's n cubed. So n cubed, n cubed. N cubed times n is n to the 4th power. N cubed times 4 is plus 4n cubed. And draw a line, change the signs. Stack add, and you get, now you have negative n cubed minus 4n cubed. Okay, so that's negative 1n cubed. Think of a number line, negative 1 minus 4. So 1, 2, 3, 4 to the left. So negative 1, negative 2, negative 3, negative 4, negative 5. Negative 5. And this is going to be negative 5n cubed. Negative 5n cubed. Bring down the minus 10n squared. And multiply what by n to get negative 5n cubed? Looking right here. What times n equals negative 5n cubed? Well, negative 5n squared times n equals negative 5n cubed. Negative 5n squared. Multiply through. Negative 5n squared times n equals negative 5n cubed. Having a hard time writing the threes. Negative 5n squared times 4 equals negative 20 n squared. Draw a line, change the signs. Stack add, these cancel. Negative 10n squared plus 20n squared is positive 10n squared. Bring down plus 33n. N times what equals 10n squared? Well, 10n times n equals 10n squared. So plus 10n. Now, 10n times n is 10n squared. 10n times 4 is positive 40n. So, draw a line and change the signs. First terms cancel. Positive 33n minus 40n is negative 7n minus 30. What times n equals negative 7n? Well, negative 7. Put negative 7 up there. So interestingly, our fourth degree polynomial, when divided by a binomial, becomes a third degree polynomial. Interesting. So a fourth degree polynomial divided by a first degree polynomial equals a third degree polynomial. That is interesting. So let's multiply through. Negative 7 times n is negative 7n. Negative 7 times 4 is negative 28. Draw a line and change the signs. These cancel, and now you have negative 30 plus 28. Negative 30 plus 28 is negative 2. We're down to where we've got a remainder. So looking back up here at our little model, what I'm going to do is write the quote whole number, air quotes, part of the proper fraction. This is n cubed minus 5n squared plus 10n minus 7. That's the whole number part of the proper fraction. And now here comes the remainder part. Negative 2 over the binomial divisor, n plus 4. And in order to preserve this indication that we are, that's fine, right? That's fine. In order to preserve that we are in fact subtracting out 2 over n plus 4, what you could often do is move the minus sign here in front of the fraction. If you put this in parentheses, it makes it more obvious. So what this is saying is n cubed minus 5n squared plus 10n minus 7 minus 2 over n plus 4. Kind of makes the language a little bit more clear. Okay, and that's number 8. All right, number 9 asks us to find the value of x, and we're given a graph. Here's the graph we're given, more or less. This is number 9. The graph we're given, more or less, looks like this. Again, more or less. Not to scale, I should say. Not to scale at all. But it looks more or less like this. And there's this kind of half moon thing. And we're given that this is 219 degrees. So totally different domain of knowledge now. We're told to find x. I love the meme where it says find x and some kid circles the x and says, here it is. I found it. I love that. This is 108 degrees. And then what they're saying is this angle right here, okay, the angle in between these two lines is equal to x minus 40 degrees. Okay, it's kind of cramped. I wrote it in there. I'll make it more clear here in a second. So here's what we can say. We know that all the angles together have to add up to 360, okay, because it's going to form a circle. So what you could say is 219 plus 108 plus, and then this, x minus 40, equals 360. So if you, in other words, if you add up all of the angles, it's going to equal 360. So we just want to know what is x. So now you just go through this process of subtracting. First we'll subtract 219 from both sides. Okay, we don't need a calculator for this test. You know, it's amazing. The more you get along in mathematics, the less you need a calculator. But occasionally you do have to do a subtraction, so it's useful to remember how to subtract. You get 141, that's gone. Now subtract out 108 on both sides. 11 minus 8 is 3. 3 minus 0 is 3. Okay. And now I have x minus 40 equals 33. And I add 40 to both sides. And I get x equals 73. Okay, x equals 73. And we can check that, can make sure that that is true by saying, what is 73 minus 40? Now, 73 minus 40 should be 33. So x equals 33. Okay, so if we put in there, we test our equation, 219 plus 108, what do I get? I get 9 plus 8 is 7. Carry the 1, 2, and 3. I got 327. Okay, and now it's saying that x is 73. Okay, so I have here 327 plus 73. Well, no, not plus 73. Well, okay, yes, plus 73. We'll do it this way. Plus 73, we'll see what we get. Now 7 plus 3 is 10. 2 plus 1 is 3 plus 7 is 10. I get 4. 400. Now subtract out 40 minus 40. And we get 360. Okay? So that's how you do those problems. You're always thinking, what am I adding up to? And in this case, it was 360. Okay, that's how you do number 9. And now we'll do number 10. Number 10, what are we given? We're given this weird looking straight line with a 90-degree angle coming off of it, like this. And this line coming down kind of like this. Okay, and then we are given that this is 90 degrees, and that's indicated with that little square angle thing. And we're given right here is 6x plus 4. And here we're given 3x plus 5 degrees, 6x plus 4 degrees. And we're asked to find out what is x. Well, you know, you can do this in a couple different ways. you could say, I know that this little square right here means 90. So that must mean that this angle plus this angle must add up to 90. So what we could write is 3x plus 5 plus 6x plus 4 equals 90. And now we just have to work out what is x. Well, we'll just start by getting rid of these whole numbers. Subtract 5 from both sides, and you get now 3x plus 6x plus 4 equals 85. Now we'll subtract 4 from both sides. Now you got 3x plus 6x equals 81. And now you add the coefficients, 3, and 6, because you have the same variables, and you now have 9x equals 81. And you divide both sides by 9. And those 9's cancel, and you're left with x equals 81 divided by 9, which is just 9. And it's useful to check your answer. 3 times 9 plus 5, we'll stack add, plus 6 times 9 plus 4. Okay, what does that equal? So we should rewrite it now. 3 times 9 is 27. 27 plus 5 equals 32. 6 times 9 is 54. 54 plus 4 equals 58. And we'll now add those two things. 32 plus 58. 2 plus 8 equals 10. And 3 plus 5 equals 8 plus 1 equals 9. So they do add to 90. And that's how I know that I got the correct answer. You got to check your work. Okay? It's not always going to be as easy as this. Yeah, that's number 10. Numbers 11, 12, 13, 14, 15, and 16, 17, 18, 19, and 20, okay, are kind of different types of problems. They're a break from what we've been doing so far in this test. These are more like geometry problems, right? But you did some of this stuff when you were younger, in 7th grade. In the first instance, we are given, I won't even try to draw it. We're given actually, we'll try to draw it. I will try to draw it and I'll use a pencil just in case this goes horribly wrong. We're given a rectangular prism, and it looks something like this. Is number 11. And we're asked to find the volume. And we're given a rectangular prism that looks like this. Trying to draw it as best I can. Okay. Okay. And now a little section over like that. See how this comes out. I've never been very good at drawing. Maybe this is really the most fun some of the students have had, since they are good at drawing. So this is going to have that kind of transparent line, and this one will have a real line. These are connected via a transparent line. And these are connected via a real line. Okay. So that looks kind of like the shape that's drawn there. It's not a masterpiece by any stretch of the imagination. But I want to encourage you to draw better than me, please. And all of you can do that. So here's the dimensions that we're given. This distance is 4. This distance is 12. This distance is 5. Okay, we really don't need all the other dimensions. We only need, look, they labeled all the way around. We only need the length, the width, and the height, because, switch back to the pen, the volume of the rectangular prism is equal to the length times the width times the height. So V for volume equals the length of 12 times the width of 4 times the height of 5. So we're going to do this without a calculator. 12 times 4 is 48. So that equals 48 times 5. And now we'll do the multiplication. 48, 5. 8 times 5 is 40. 4 times 5 is 20, plus 4 is 24. So 48 times 5 is 240. Okay, and remember that's going to be cubic inches. Okay, that was number 11. And now on to number 12. Oh dear. Oh dear, oh dear, oh dear. Here we're given a cylinder. And I just know that those are little monsters. So I will bring in the use of the pencil to help me draw this cylinder. Really do think I should have encouraged you guys to draw more shapes this year. We didn't do a lot of drawing of geometric shapes until the end of the year, mostly because drawing shapes wasn't part of the STAR readiness, but now I regret it. So anyway, we'll draw a kind of like the bottom of the cylinder, like that. Draw with our compass. At least you'll get to draw a lot of shapes in geometry, for sure. Okay, and then okay, and we can use our compass again to finish drawing this. Whoops, didn't quite make it there, did I? Okay, so there's the other half of the drum, or whatever this is, like this cylinder that's on its side. I see what's wrong. I'm not properly bisecting this angle. Okay, so this is our cylinder. See if I can't make this a little bit more clear. Okay, so there's a cylinder, and the cylinder has a radius of 4 kilometers. And it has a length of 10 kilometers. I mean, it's a huge cylinder. My goodness. Okay, so how do we find the volume of a cylinder? Okay, so a cylinder, if you think about it, the reason I utilize the compass here is because a cylinder is really just a whole bunch of circles stacked on top of each other. See, if I see if I can. The way to think about it is I could have drawn many of these lines. See this? Could draw a whole bunch of them. So it's like a whole bunch of circle areas stacked up on top of each other. That's what the cylinder is. See that? I'm just stacking circles up. And so what I need to do is find the volume of a cylinder. I'm going to write it this way. The volume of a cylinder is equal to the area of the circle times length. Okay, so what is the area of the circle? Well, we have to now know what the area of a circle is. The formula for the area of a circle, the area of a circle is equal to pi times the radius squared. Oh, so we just kind of fill in the blanks here. What is the radius? The radius is, so we'll rewrite, equals pi times something squared. What's the radius of the circle? It's got to be 4. So now it's pi times 4 squared. So this is the area of the circle is going to be 16 pi. That's the area of the circle. And now we just have to multiply that by the length, which is 10 kilometers. Okay? And that will give us the total number of volumetric kilometers, which is 160 pi cubic kilometers. Right, so that's the volume of a circle, of a cylinder. Okay. That was a fun one, I think. I like doing cylinders. Now you're given, next up is a sphere. So a sphere is just a circle in 3 dimensions. So this next one is just a circle in 3 dimensions. The way they indicate that is with, first they give us a radius, and that radius is given to be 4 miles. And then they, you kind of dot in these little half moon shapes. See if I can do that without butchering the picture. This is what makes it look spherical. We kind of put in these little dotted half moon shapes to indicate 3-dimensional nature of the picture. Okay, it can't really show up very well, does it? And now, if you don't know what the formula for the sphere is, you just go back and look at the formula sheet. Were we given the volume of a sphere? Sure. It was 4/3 pi r cubed. So the volume of a sphere is equal to 4/3 pi r cubed. Okay, so all we have to do is plug in for what r is. Everything else is given to us. So r is 4. So the formula becomes 4/3 pi 4 cubed, like that. Now, I probably should have mentioned this in the cylinder example. We're not evaluating pi to a decimal. We're keeping it exact. We know that pi is 3.14159.265, whatever. But then it just goes on and it never, ever, ever repeats. So we're just going to leave it as this little symbol for pi because that's exact, as opposed to some inaccurate or with limited accuracy decimal approximation. Well, anyway, now I need to use PEMDAS, okay, exponents of the parentheses. So I got to take 4 times 4 times 4. What could that be? Well, 4 times 4 is 16. So 4 times 4 gives me 16. And then I can multiply by that final 4. 16 times 4. 6 times 4 is 24. 4 times 1 is 4 plus 2 is 6. So 16 times 4 is 64. So this volume is equal to 4/3 pi times 64. Okay? So now what? Now I need to multiply my two whole number numerators because I've essentially got this following problem. I have 4 times 1/3 times pi times 64. And I've got to resolve this somehow. So first I'm going to multiply 4 times 64, and then I'll divide everything by 3. So what is 4 times 64? 64 times 4. 4 times 4 is 16. 6 times 4 is 24, plus 1 is 25, 256. Let's make sure it's divisible by 3 by adding up the digits. 2 plus 5 is 7. 7 plus 6 is, did I do that right? 64, 16, 24 plus 1 is 25. 7 plus 6 is 13. Okay, so it's not going to be evenly divisible by 3, but we'll do it anyway. Let's see what happens when we divide 256 by 3. See what I did there? I added 2 plus 5 is 7. 7 plus 6 is 13. 13 is not divisible by 3. So when I divide this, I know I'm going to have a remainder. So we'll divide by 3. 3 goes into 2 0 times. So 3 goes into 25 8 times. 8 times 3 is 24. 25 minus 24 is 1. Bring down the 6. 3 goes into 16 5 times. 5 times 3 is 15. Okay, and we're left with a remainder of 1. Now we now know to write 85 1/3. Okay, but what is that as a decimal? 85.333 forever, right? The 3 just goes on forever. Dot, dot, dot. So the answer is 85.3 repeating pi. You see how I did that? So if you consult your answer choices, there should be something that looks like that. Miles, cubic miles, volume of a sphere. Awesome. And now next up is the volume of a cone. I feel like I'm getting a little bit cramped over here on this page, but I'll I'll try it anyway. So we got to draw this little cone thing. Now, you know, a cone looks kind of like a triangle, so I wonder if the volume of a cone has something to do with the triangle. I really don't know. We'll look at the formula and see. But these are just so much fun, you know, these little volume problems. This is what makes math fun. I always miss this. I mean, I did this in, when would I have done this? When I've, 7th grade? Maybe 7th grade we did this, and then we never did it again. We never drew the shapes. And I always miss drawing the shapes because it was fun. So this is my version of a cone. Oops, that'll happen. So, and then this comes around the back end to indicate the three-dimensional nature. And we've got a few things that we know about our cone. We have a radius of, actually not sure what this indicates. This is what we were talking about. Does this indicate the diameter or the radius? I mean, you look at that. Look at this. Is that 12 on the bottom right there? Is that the radius of that circle or the diameter of that circle? I mean, I guess it's the diameter because everywhere else, when they indicate a radius, it's only dotted halfway across. But that could have been made more clear. I'm going to be honest with you. That could have been made more clear. So we'll go with this. We'll indicate that the radius is 6, since that makes more visual sense. And then this height, should have been doing that with a dotted line. Oops, whatever. The height is 12 miles, and the radius is 6 miles. Okay, so let's see what's going on here. What is the volume of a cone? Looks like an ice cream cone turned upside down, like a Dairy Queen. I've always wanted to see one of those blizzards fall out of the cup. Okay, so the volume of a cone is equal to pi r squared times height over 3. Pi r squared times height over 3. So we're saying that the volume of a cone, volume of a cone is equal to pi r squared. Well, pi r squared is just the area of a circle times height divided by 3. Interesting. So I thought it would include, I honestly thought it would include something about a triangle, but it didn't. It includes, it's the area of a circle times height over 3. You see pi r squared is the area of a circle. Let's find the area of the circle. So the area of the circle is equal to pi times 6. That's the half the diameter is the radius. Okay, and they gave us that the diameter was 12. So we take half the diameter. That's the radius. 12 divided by 2 equals 6. That's equal to the radius, which is half the diameter. I should say radius equals 1/2 the diameter. We were given the diameter. So now I have to square 6. 6 squared is 36, so the area is 36 pi. So now I multiply 36 pi times whatever the height is, and then divide by 3. So 36 pi, so now volume is equal to 36 pi times the height, and then I'll divide all of that by 3. Okay, so what do I plug in for height? 12. So I need to do 36 times 12. I already see how this could be made easier, but we'll just do it. 36 times 12. 6 times 2 is 12. 3 times 2 is 6, plus 1 is 7. 6 times 1 is 6. 3 times 1 is 3. 2, and then 7 plus 6 is 13. Carry the 1. 432. So 432 pi pi over 3. We need to simplify that by dividing 432 by 3. Is it evenly divisible? 4 plus 3 is 7, and 7 plus 2 is 9. So yes, 432 is divisible by 3. So we'll just do that here, maybe over here, 432 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. Bring down the 3. 3 goes into 13 4 times. 4 times 3 is 12. Remainder 1, bring down the 2. 3 goes into 12 4 times, so 144. So this equals 144 pi cubic miles. Neat. Very, very cool. Oh, I love this. This is just too much fun. We should have been doing this all year. I miss this stuff. To find out where they teach this and go teach that grade. I like that. I like drawing pictures like that. Okay, so what's the next shape? Number 15. We're drawing a square-based pyramid that has 4 sides, just like the Great Pyramid of Giza. Right? So first we have to draw this. Oh, they want to make it hard, don't they? We have to draw this square, but it's got to be kind of at an angle. We'll see if I can do that. I'm sure I'll butcher it. Try. So here comes number 15 with a pencil. Old school. All right, so here's the base of the pyramid. It's got a square base. Okay, and now I'm making the base 2 centimeters long. I better make it 2 centimeters square. It's 2 centimeters, right? Centimeters. Yep. And now we do 2 more centimeters. Make sure it's at the same angle. The way I do it is I line up the ruler and then pull slowly, try to maintain that same angle. Sometimes it takes multiple attempts. More of like an eyeball it situation. You did that a lot in trade work. You just eyeball it. You'd be surprised at how much trade work is done by guessing. It leads to some shocking results, which is why repairmen love bad repairmen. More money for them. Good repairmen love bad repairmen. Okay, so now we put in another dotted line here. And that we should indicate that these are all square, these little 90-degree symbols here. Now it looks like we're playing baseball or softball. This is 5 centimeters, and this is 5 centimeters. Okay, and now we are going to locate the top of the pyramid here-ish, about right there. And if I follow the picture, I'm going to connect these sides here and here and here. And then I will be doing a dotted line to the back sides. Yeah, that does not look like the way it's drawn. Okay, then drop the height, which is going to be right here. Okay, does not look very much like that picture, does it? Oh well. and that height is indicated as being 7 centimeters. Okay, so how do we find the volume of a square-based pyramid? Okay, so this is a right square pyramid. So the volume equals a squared times h over 3, where a is the base edge and h is the height. Okay, so a squared times h over 3. So volume equals a squared times h over 3. And a squared is the base edge. So that's equal to 5 times h, which is 7, over 3. So 5 times 7 is 35. 35 divided by 3. That's what we need to do. 3 plus 5 is 8. 8's not evenly divisible by 3, so we will end up with a decimal. Whatever. So 35 divided by 3. 3 goes into 3 one time. 1 times 3 is 3. 3 minus 3 is 0. Bring down the 5. 3 goes into 5 one time. 1 times 3 is 3. 5 minus 3 is 2. And now we write down 11 2/3. That's the answer. And if you evaluate 2/3 out, you get 0.66666 forever. So this is equal to 11.6 repeating. I guess I want you to take it out a decimal point or two. And then since it's volume, it's going to be centimeters cubed. Should be something like that. I must have done. Oh, I did something wrong. I forgot to square the term first. Whoops. So made a mistake here. I plugged in 5, but I didn't square it. That's because I'm exhausted. So we're going to have to redo some of this work. Lo siento. Hope some of you caught it. If you are currently patting yourself on the back, good. Luckily, I have liquid paper, which erases all sins. There we go. It never happened. Okay, so sorry about that. You just start getting into the rhythm of the problem and you forget to do what you know you need to do. So what is 5 squared? 5 squared is 25. And 25 times 7 is 5 times 7 is 35. 2 times 7 is 14 plus 3 is 17, 175. So this is 175 divided by 3. 1 plus 7 is 8. 8 plus 5 is 13. 13 is not evenly divisible by 3, but we'll do it anyway. So we'll do 175 divided by 3. 3 goes into 17 5 times. 5 times 3 is 15. 17 minus 15 is 2. Bring down the 5. 3 goes into 25 8 times. 8 times 3 is 24. 25 minus 24 is 1. So I have now 58 1/3. Okay, and that's, that evaluates out to 58.3 repeating, and they want centimeters, cubic centimeters. Okay, sorry about the mistake. It happens. And now on to number 16. Number 16 is very similar to number 15, only now we're dealing with a 3-sided pyramid. There's a movie, it's a found footage horror movie called The Pyramid, and it's all about the discovery in Egypt of a three-sided pyramid, and they'd never found one before, and that's what the movie's all about. So just draw the pyramid here. All the pyramids in Egypt have four sides on their base. You know, something you probably never thought about until you actually sit down and think about it. Okay, so there's the base, and then they have this three-sided thing indicated like this. Alrighty, and here, there. Then they've got the height drawn. Oh, this is just so much fun to draw these shapes. I'm gonna have to do more of this next year for those kids coming in. They will really enjoy drawing the shapes. There's a little bit of a break from the kind of monotony of just writing the algebraic equations over and over and over. It drives you crazy, doesn't it? Okay, so the height there, that right there, is given as 11 centimeters. And this distance right here, I don't know what you'd call that. One of the base edges, the longer base edge, is given as 8 centimeters. This, which is actually the hypotenuse of that triangle laying down on its side, is 10 centimeters. And then this little short edge over here is 6 centimeters. So let's go find out how to find the volume of a three-sided pyramid, or a pyramid with a base of 3 sides. Where's my formula page? Here it is. So a triangular pyramid, cool. 1/3 times A times H, where A is the base area. So this is different. Where A is the base area and H is the height. So remember, up here with the right square pyramid, A was the base edge. Here, we're actually going to have to compute the base area. So A is representing two different things in these. So A is the base area. Well, what is the area of this base pyramid here? Well, if you think about that base pyramid, the base triangle. The base triangle, if I just bring it up, it has 6 and 8 and 10 right there. So we have to multiply base times height divided by 2. So that's 6 times 8 divided by 2. 6 times 8 is 48. 48 divided by 2 is 24. So this is 24. So I'll make sure I'm doing that right. 6 times 8 is 48. 48 divided by 2 is 24. So 24 centimeters square. And now I'm going to multiply that times, it says 1/3 times that. So now we'll take 1/3 times 24. And that's just 24 divided by 3, so that's 8. Okay? Because the formula I'm trying to put in here is volume equals 1/3, and then it's area of base times height. Okay, so 1/3 times the area of the base is 1/3 times 24, and that equals 8, and then times 11, because 11's the height. So I'm getting 88, and that's centimeters, 88 cubic centimeters. Cool. That was really fun. That was like a trip down memory lane. I really enjoy that. I think the last time I did all that was probably 8th grade. So that was fun. That was fun, fun, fun. Just goes to show you, all through college, we never drew shapes like that. And when I took calculus in college, we never drew shapes. I misdrawn the shapes. Okay, number 17. Number 17. New section. They want us to find the missing side of the triangle. Okay, so this is like a Pythagorean theorem section. And we'll talk about all that. No worries. Okay, so here's number 17, and they give us this triangle, and we're given that this is 11 feet, and this is 9 feet, and this is the missing side. So they want us to find the missing side. And what we need to use is the Pythagorean theorem. Okay, what is the Pythagorean theorem? Let me write it up here. The Pythagorean theorem, Pythagoras lived in 600 BC, or maybe it was 650. So how long ago was that? Well, that was like 2,000 years plus like 2,600 years ago. Okay, more than 2,600 years ago. This guy lived. He came up with all this cool stuff. And this is just the tip of the iceberg with this guy. He came up with all kinds of crazy stuff. Pythagorean theorem. For centuries, all musical instruments were tuned to a frequency of 432 hertz. Remember, 432 appeared earlier in the homework, but that was Pythagoras' favorite number, 432. It has all these weird, you should look into it. Look up 432 hertz kymatics, Cymatics. 432 hertz kymatics. Anyway, the Pythagorean theorem is a squared plus b squared equals c squared. Actually, Pythagoras was that whole thing with the kymatics. You should look it up. It's like they make sand. Type in sand kymatics 432, and you'll see the sand change shapes. It's very, very strange. That's what got me into math. Getting back into that, looking into all that weird stuff from Pythagoras. And then if I wanted to find one of these missing sides, I would just solve for that. So let's label our sides. Let's label x as A, and 9 as B, and 11 as C. And just plug in now. So I've got x squared plus 9 squared equals 11 squared. And what is it that I want to do? I want to solve for x, right? So I'll subtract 9 squared from both sides. And now I've got x squared equals 11 squared minus 9 squared. Now how do I get rid of a squared term? Take the square root. Okay. Now when we take square roots, and the way I've been showing you guys to do this, when you take the square root of x squared, you just get x. So what does x equal? X equals the square root of 11 squared times 9 squared. So rather than actually multiplying all that out and subtracting it, I want you to think about what you're doing, right? You're squaring 11, and then you're squaring 9, and you're taking the difference. So 11 times 11 is 121. 9 times 9 is 81. 121 minus 81 equals 40. So x is equal to the square root of 40. And you look in your answer choices, you're not going to find the square root of 40. You have got to prime factor that 40. Okay, so what can I break 40 down into? Start with a prime number. 2 times what? 20? Now break down the 20. 2 times 10. Break down the 10. 2 times 5. All right, so here are my prime factors. 2 times 2 times 2 times 5. So what I want to do is rewrite this as, let me make some space here. I'm going to move this whole thing over here. X is equal to the square root of 2 times 2 times 2 times 5. Okay, and what I'm looking for is I can pull out, when I see 2 2's, I can pull out a 2. Like I can pull out a 2, and then that cancels what's inside. So I don't see any other pairs. So now I rewrite this as 2 square root, then you just multiply 2 times 5. 2 times 5 is 10. So that's how you get to 2 square root 10 feet. That's the missing side. If you plug that back into the Pythagorean theorem, you would get 11 squared. If you did 2 square root 10 squared plus 9 squared, it would equal 11 squared. Just to prove it, 2 square root 10 squared plus 9 squared equals 11 squared. That's how you check. And so what is 2 square root 10 squared? Well, it's 4 times 10, because you're distributing the 2 to each of the terms inside, because this is really 2 times the square root of 10. 2 squared is 4, and the square root of 10 squared is just 10. So now it's 4 times 10 plus 9 squared equals 11 squared. Oh, well, what's 4 times 10? That's 40 plus 81 equals 121. Does it? What's 40 plus 81? Well, 81 plus 40. 1 and then 12. Yeah, sure. 121. That's 121 equals 121. This is how you check your work. You show this to your geometry teacher, they're going to stand and stare and wonder how you know how to do this. And you'll tell them, I learned it last year. Okay? This problem is super, super, super good to know how to do. It's a good demonstration of like a lot of different things at once. And it proves why you need to know how to prime factor. It's going to come up, guys. It's going to come up next year. On to number 18. Number 18. We are given this right triangle. Okay? And this is 8 kilometers. And this is x. And this is 14 kilometers. We got to label our points. Label our sides. Like what's A, what's B, what's C. So we'll label this as A, the short side. We'll label X as B, the long side. And then the hypotenuse is C. And if you ever wonder, what you need to do is kind of look, put a little eyeball here on this right angle and look and see what's across the street from the right angle. Okay, whatever's over there, that's the hypotenuse. It's across the street from the right angle. You're trying to figure out what's A, what's B, what's C. You can find out what C is. It really doesn't matter what you label A and B. Anyway, now let's solve it. So Pythagoras told us that A squared plus B squared equals C squared. This is one of the few things from mathematics. It's like, I'm going to be honest with you, nobody's ever asked me in my working life to do a quadratic equation, factor a quadratic equation. I have used the Pythagorean theorem many, many times, especially in trade work, working out in the trade fields, electrical, plumbing, HVAC. It comes up all the time. Okay. So let's plug in what we know. Well, we know A is 8. So 8 squared plus B squared, which is x, so x squared, equals 14 squared? We'll have to figure that one out. I don't know 14 off the top of my head squared. But anyway, so I'll subtract 8 squared from both sides. Get x squared equals 14 squared minus 8 squared. And we'll take the square root of both of those. And I've got to find out what 14 squared equals. So 14 times 14 equals 4 times 4 is 16. That's 56. And then 4 and 1, 196. So then 8 squared is 64. So 8 times 8 is 64. So I need to do 196 minus 64 to do 14 squared minus 8 squared. 6 minus 4 is 2. 9 minus 6 is 3. And 1 minus 0 is 1. So I'm really saying that x is equal to the square root of 132. And what's left to me is to prime factor 132. Let's start by dividing by 2. I don't even know what it is. 2 goes into 13 6 times, and then another 6. Is that true? 66 times 2? Yeah. Okay, so I just divided 132 by 2, and I got 66. Okay, so let's prime factor 66. 2 times 33. Prime factor 33. 3 times 11. Those are all prime numbers. And I already see my pair. See my pair of 2's? Then I got a 3 and an 11. So when I rewrite this, this equals the square root of, and then that's the product of all these primes. 2 times 2 times 3 times 11. Okay, so now I'm taking the square root, and I'm going to simplify this square root by, I'm going to cross these out and pull out 1, 2. That's the only way you do that. So this is equal to 2 times the square root of 3 times 11, which is 33. And that is centimeters, or kilometers, I'm sorry, kilometers. Weird looking K. If you're interested in looking up that stuff about Pythagoras, look up 432 hertz and look this up. Kymatics. Kymatics sand. Type that in. Kymatics sand in YouTube. There's such a cool video on it. Anyway, it's amazing. It's amazing. They increase the frequency and then the sand just changes shapes. It's insane. Okay, now we'll do 19 and 20. And 19 and 20 tell us to find the area of each triangle. Round intermediate values to the nearest tenth. Use the rounded values to calculate the next values. Round your final answer to the nearest tenth. Okay, so this rounding intermediate values will be important to the nearest tenth. Okay, so number 19. Do some triangle math here. These look hard. They're really not. It's really just the combination of two triangles. So let's see what they give us. They always try to trick you in some way. Okay, so we're given the hypotenuse of the small triangle, the hypotenuse of the big triangle. We're told that this is a right angle and that this short side right here is 10. So my recommendation is to solve for the height. Okay, so if we think about this, we have this triangle right here. We could break this thing up into two triangles. I've got this triangle, and we're given at 41, right? I don't know what this distance is. This is unknown. And right now this is unknown. That's the height. Okay, right angle. And then over here, I've got this other triangle. They share the same height, right? You see that? It's a little triangle. That's what I'm going to draw now. Got this little tiny triangle right here. And it's also a right triangle. And they share the same height, but we're given that this is 10 and this is 29. So, those combined together give you that big triangle. And that's how you got to solve these, one triangle at a time. So now I got to do Pythagoras. A squared plus, this is the small triangle. Okay, small triangle area. Or area, well, I guess I don't need to find the area. Do it. I find it? Yeah, I do find the area. Small triangle area. A squared plus B squared equals C squared. And 10 will be A, and then we don't know what B is. We're trying to find B, and then 29 will be C, the hypotenuse. So C is always the hypotenuse. I don't know if that was made clear. C is always the hypotenuse. So now A squared, that's 10 squared, it's 100, plus B squared equals 29 squared. Okay, so subtract 10 squared from both sides. And now I have B squared equals 29 squared minus 10 squared. And the way we're going to find it is by taking the square root of both sides. So I got to find out what 29 squared is. And the only way to do it is to multiply 29 times 29. 9 times 9 is 81. 2 times 9 is 18. Plus 8 is, what is that? 18 plus 8. Is that 26? Can't even think anymore. Yeah, 26. So 26. And then 9 times 2 is 18. 2 times 4 plus 5. And then add this up. 1 and 14. 841. Just do that one more time to make sure. 29 times 29. I'm just never sure when I start doing hand-based multiplication. 9 times 9 is 81. And then 2 times 9 is 18. 19, 20 to 26. Yep, it's 26. Okay, 9 times 2 is 18. And 2 times 2 is 4 plus 1 is 5. And then we add 1. 6 plus 8 is 14. And then 5 plus 2 is 7 plus 1 is 8. 841. Okay, well, I'm satisfied. So now we take 841. That's 29 squared. Let's subtract 10 squared. 10 times 10 is 100. So 841 minus 100 will give us 29 squared minus 10 squared. So that's 741. Okay? All right. So I now get B is equal to the square root of 741. Well, we got to break down 741. We can't just rest on our laurels. So we got to break down 741. Now 741 is an odd number. So the question is, it can't be divisible by 2. So can it be divisible by 3? Well, here's the trick. This is the trick. You add up the numbers. 7 plus 4 is 11. 11 plus 1 is 12. Since 12 is divisible by 3, then we know 741 is divisible by 3. So my lowest prime number is going to be 3. And I'll do this over here. 741 divided by 3. Okay? 3 goes into 7 2 times. 2 times 3 is 6. 7 minus 6 is 1. Bring down the 4. 3 goes into 14 4 times. 4 times 3 is 12. 14 minus 12 is 2. Bring down the 1. Bingo. 3 goes into 21 7 times. Okay, so 247. So 3 times 247 equals 741. Is 247 divisible by 3? 2 plus 4 is 6. 6 plus 7 is 13. So no, it can't be broken down. So the question is 241 divisible by 4? Nope. How about 5? Nope. 6? Nope. 7. I mean, we could try 7. 247 is divisible by 7? I don't know. 7 goes into 24 3 times. 3 times 7 is 21, and 24 minus 21 is 3. Bring down the 7. 7 goes into 37 5 times, but we have a remainder of 2. So that doesn't work. How about 9? Okay. See, 247 by 9. 9 goes into 24 twice. That's 18. And that is 67. Nope, it doesn't go in evenly. It goes into 9 times, what would that be? 9 times 8 is 56. 9 times 9 is 81. Wait a minute. 7 times 8 is 56. 9 times 8 is 72. 9 times 7 is 63. So this goes in. My goodness, I forgot my multiple. 7 times 9 is 63. Okay, 67 minus 63 is 4. Had to remember there. 9 times 8 was 72. So 9 times 7 is 63. Whew. Okay, there's a remainder. So what I'm doing over here is I'm discovering that 247 feels like prime-ish. Okay, so I don't think that there's really any way to break down that number. So we have to take the square root of 741, and there's no way around using a calculator to do it. I wonder if I have like a little calculator that doesn't have a ton of bells and whistles. We'll just do this one thing that I needed to do. Maybe we'll use the phone if all else fails. And it appears all else is failing. So we'll use the phone. Okay, let me get my phone. Be a good calculator. Okay. So if you're going to use your phone as a calculator and you want to get to the square root, I mean, it's different for an Android, but turn it on its side, and we'll take the square root of 741. 741, and then take the square root. Where's that? There it is. 27.22. Remember they said round to the nearest tenth? So we'll say b equals 27.2. All right, so the height is 27.2. This value right here is 27.2. And now that I know that, I can find the area of this triangle. So the area of the small triangle, let me go back here. The area of the small triangle, is equal to base times height divided by 2. So 27.2 being the height times the base of 10 divided by 2. So that's 272 divided by 2. 272 divided by 2. And you got 1, okay, 7, it goes in 3 times, and then 4, 134. So 272 divided by 2 is equal to 134, and that is what dimensions? It doesn't give us, so just 134 units squared. So we found the area, this area right here, this area is equal to 134 units squared. Now we'll find this area because we'll find the missing side first, because now we know the height. And so we can use the Pythagorean theorem on this triangle to find the base, right? So now we're going to be focused on, okay, drew a line down here. We're going to be focused on this other triangle here, this triangle. Okay, I now know this height is 27.2. This base is unknown, so that's unknown. And then the hypotenuse is 41. Okay, so this is going to be A, this will be B, and 41 will be C. Okay, so A squared plus B squared equals C squared. Well, we don't know A, so it's A squared is unknown, plus B squared, that's going to be 27.2 squared equals C squared. But so we'll just put 27.2 squared equals C squared, which is 41 squared. So to get A by itself, we'll subtract out 27.2 squared on both sides. Notice where I put the minus sign, okay, outside of the squared. Think about PEMDAS. So what I'm trying to tell you about that is eventually you're going to need to square 27.2, but don't put that negative sign in there or it'll disappear on you. Okay, so now I've got A squared is equal to 41 squared minus, open parentheses, 27.2 squared. To get A by itself, I'm going to, okay, take the square root of both sides, and we are going to multiply. We got to figure this internal stuff out before we can take the square root. So I got to do some side work, maybe over here. 41 times 41. Okay, so 1 times 1 is 1, 4 times 1 is 4, 1 times 4 is 4, 4 times 4 is 16. So 41 times 41 is 1681, 1681. Okay, now how about 27.2 squared? Well, it's been many years since I've done this, but let's do that by hand. 27.2 times 27.2. Alrighty, so now I'm going to put 4, and then just deal with this as if it's a a 3-term multiplication. 7 times 2 is 14. 2 times 2 is 4 plus 1 is 5. 2 times 7 is 14. 7 times 7 is 49 plus 1 is 50. Carry the 5. 2 times 7 is 14 plus 5 is 19. Okay, I'm going to run out of space. 2 times 2 is 4. 7 times 2 is 14. Carry the 1. 2 times 2 is 4 plus 1 is 5. And so now I'm going to stack add all that. 4, 8, 9, 13, carry the 1, 5, 6, 7, 7, 3, 9, 8, 4, and then we put decimal point there. And it's rounded to the nearest tenth is 739.8. I want to double check that, see if I did math wrong. 27.2 times 27.2. Okay, prepare to mock me. 739.84. Okay. I don't know why that feels like an accomplishment, but it's been years since I've done 3 by 3 like that. We should probably practice that more often. Okay, so now I'm going to have to do a huge subtraction problem. Oh, brother. I need to subtract 739.8 from 1681. See, because I got 1681 minus 739.8. And it's so tempting to use the calculator here. Oh, it's so tempting. It's so tempting. I want to, but then I would be breaking my own rule. 1681 minus 739.8. I gotta run out of space here, so 1681.0 minus 739.8. Ugh. We did need the calculator for the square roots, okay? So I wasn't entirely, but anyway. So borrow 7, 10, 10. Okay. 10 minus 8 is 2. 10 minus 9 is 1. 7 minus 3 is 4. 6 minus, okay, borrow. 16 minus 7 is 9. So is it in fact true that 1681 minus 739.8 equals 941.2? Good. Awesome. Let's go back here. So 941.2 is what I'm going to take the square root of. So a equals the square root of 941.2. Oops, right there. So what is that square root? This one we do need the calculator. Take the square root. 30.67, round to the nearest tenth, so 30.7. So a equals 30.7. All right. So that was the missing side here, 30.7. And now what we need to do is multiply base times height divided by 2. So 30.7 times 27.2 divided by 2. 30.7 times 27.2. 30.7 times 27.2. 30.7 times 27.2. Okay, 7 times 2 is 14. 0 times 2 is 0, plus 1 is 1. 3 times 2 is 6. 7 times 7 is 49. 0 times 7 is 0, plus 4 is 4. 3 times 7 is 21. Okay, 7 times 2 is 14. 0 times 2 is 0, plus 1 is 1. 3 times 2 is 6. Again, I hope I did that right. Let's do this. Okay, let me add that up. This is 4, this is 0, 1, 6, 7, plus 4. 7 plus 4 is 11, plus 4 is 15. 1 plus 1 plus 1 is 3. 2 plus 6 is 8. So it's 835.04. Is that correct? Let's see. 30.7 times 27.2 equals 835.04. Round to the nearest tenth. So this is 835. So I'm going back here, and so base times height is 835. Now I just need to do, so area of this triangle is equal to 835 divided by 2. Oh, well, what is that? Well, take 835 and divide by 2. We'll see what we get. 2 goes into 8 4 times. Okay, 2 goes into 3 1 time. It's 1 left. 2 goes into 15 7 times. Okay, so like 7 times 2 you'll be left, it's 14, so you'll have a 0, and then you'll drop down, you'll make a 10, 2 goes in 5 times. So it's 417.5. So just to show what I did there, I was doing it in my head. 2 goes into 8 4 times. 4 times 2 is 8. 8 minus 8 is 0. 2 goes into 3 1 time. 1 times 2 is 2. 3 minus 2 is 1. 2 goes into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1. So we put a dot and we invent a 0 and bring it down. 2 goes into 10 5 times. So 417.5. That's the area. This is the area of the bigger triangle. So now we have to add the areas together. So this was equal to 417.5. 417.5. Okay, so flip. So now we have to add those two areas together. Make a little box here for our final answer portion. So we have the area of the tiny triangle, which is equal to 134 units rounded. And then the area of the bigger triangle is equal to 417.5. Right, so we want to know the total area. Well, we need to add 134 to 417.5 because we want to add together these two areas. See, now we know this area. Okay, this area right here is 417.5. So we now add together the two areas to get the full area. So that's what we're going to do down here. See what we get. 5 plus 0 is 5. 7 plus 4 is 11. Carry 1. 3 plus 1 is 4 plus 1 is 5. And 4 plus 1 is 5. So the total areas combined are 551 units squared. And I'm going to show the answer choices here. We have some kind of discrepancy here. So I've got 553.5 as the correct answer choice, but I came up with 551. So unless I made a clerical error along the way, which I'm not sure I did. Let me see what. Let me see here. So 835. Let's do 835 divided by 2. Make sure that was correct. Then what exactly did we do? We added that to 134. 134. 551.5. Now, so the correct answer should be, unless I've done something wrong, 551.5. My guess is that, it's got to be C. But my guess is that this is where something went wrong. Okay, find the area of each triangle, round intermediate values to the nearest tenth. Okay, so something with this one, rounding intermediate values to the nearest tenth, use the rounded values to calculate the next value. I feel like if you back the tape up, that's exactly what we did. But maybe we didn't do it right somewhere. Maybe we didn't round, because it said to the nearest tenth. So we rounded to the nearest tenths place each time. So I don't know. Maybe that's wrong. It'd be worth sending it to the Unless you saw the error and you're laughing right now. Okay, on to the final problem, number 20. That was fun. Look at that. Look at how much math it took to actually find the answer. It's crazy, right? Okay, number 20. Okay, number 20. Numero 20. This is the final problem. We've done it. We've made it. So we're going to draw this triangle here and find its area. Except for those square roots, we did not use the calculator except to check our answers. So here's 20, and we're given this area here. Okay, and then there's a little drop-down box, this, and a right angle indicator. Okay, so this is 24, and this is 8, and this is 14. So again, we have two different triangles that we're going to calculate. The first thing we're going to try to do is to find the height here by using the Pythagorean theorem on this little triangle. Then we'll find the area of that little triangle, and then we'll use the Pythagorean theorem to find this missing value here, and then we'll put x times h divided by 2. So at least we know the process now. So first things first, we're going to find h. So here's how that works. 8 squared, because it's a squared plus b squared equals c squared. I can make this a, and this will be b, and this will be c. So 8 squared plus h squared equals 14 squared. Okay, so I'm going to subtract 8 squared from both sides, and I get h squared equals 14 squared minus 8 squared. And to get h by itself, I'll take the square root of both sides. And now I need to do 14 squared. 14 times 14, don't know what that is. 6, 1, 4 times 1 is 4 plus 1 is 5. 4 and 1. 196 minus 64. Okay, because 8 times 8 is 64. 196 minus 64. 6 minus 4 is 2. 9 minus 6 is 3. 1. So square root of h squared is h equals the square root of, and we took that difference just now, right here, is the square root of 132. But unlike that other problem where we factored 132, here we actually need to approximate the root. So we will take the root of 132, take the square root, and you get 11.48, and we'll round up to 11.5. H equals 11.5. Okay, so that's H. Now we can find the area. So this is the area of the small triangle. Okay, is equal to base times height divided by 2. And that is equal to the base, which is 8, times the height, which is 11.5, divided by 2. So now what? I need to multiply 11.5 times 8. 5 times 8 is 40. Okay, 8 times 1 is 8, plus 4 is 12. 8 times 1 is 8, plus 1 is 9. 92. So 92 divided by 2. So this is equal to 92 divided by 2. 92 divided by 2. 2 goes into 9 4 times. 4 times 2 is 8. 9 minus 8 is 1. Bring down the 2. 2 goes into 12 6 times, so this is 46. 46. All right, that's the area of the small triangles, units squared. So we need that here. We'll need it later, but we'll put a little box around it so we know this is the area of the small triangle, 46 units squared. Now we will use the fact that we know that h equals 11.5. We'll use that to calculate x. So let me do this now. We got to find, first we got to find out what x is. So go up here. We'll now set, let me redraw this because it's going to be confusing. We're going to find the area of this bigger triangle. Okay. This is h equals 11.5, and this is x, and this is 24. Now, 11.5 will be A, x will be B, 24 will be C. So A squared plus B squared equals C squared. And we'll plug in what we know, okay? So it's 11.5 squared plus B squared, which is x squared, equals C squared, which is 24 squared. All right, so let's subtract out open parentheses 11.5 squared from both sides. Subtract out open parentheses 11.5 squared. Okay, so now you have x squared equals 24 squared minus open parentheses 11.5 close parentheses squared. Right, and if I want to get x by itself, I take the square root of both sides. Okay, so the square root of x squared is x, and that is set equal to the difference of 11.5 squared and 24 squared. So first we got to figure out what those are, and then we have to subtract one from the other. So first let's do 24 squared. So 24 times 24, that's 16. 2 times 4 is 8, plus 1 is 9. 4 times 2 is 8. 2 times 2 is 4. 6, 7, 5. 576. And now I need 11.5 times 11.5. Okay. You know what? I'm going to rewrite it because I'm going to run out of room. 11.5 times 11.5. Okay, 5 times 5 is 25. Carry the 2. 2 times 5, or 1 times 5 is 5, plus 2 is 7. And then 1 times 5 is 5. 5 times 1 is 5. 1 times 1 is 1. 1 times 1 is 1. 5 times 1 is 5. 1 times 1 is 1. 1 times 1 is 1. Okay, so there's my 3 rows. This is 5. To add 7 plus 5 is 12. 1 plus 5 is 6, plus 1 is 7. Plus 7 plus 5 is 12. 1, 2, 3, and 1. Okay, so that goes over 2. So it's 132.25. And that rounded to the nearest tenths place is 132.3. Maybe that's where I went wrong earlier. I don't know. So now I need to take 576 because look, this is 576 minus 132.3. All right. So now I got to take 576.0 minus 132.3. All right. Borrow. 10 minus 3 is 7. 5 minus 0.5 minus 2 is 3. 7 minus 3 is 4. 5 minus 1 is 4. 443.7. Okay, so now I need to take the square root of 443.7. Before we do that, let's just make sure that there were no like weird errors anywhere. So let's just say 24 times 24, 576. Okay, that checks out. 11.5 times 11.5 equals 132.25. We rounded up to 132.3. And then 576 minus 132.3 equals 443.7. Good, all of our math checks out. And now we just need to take the square root of that number and round it to the nearest tenths place. So we get x equals 21.1. See, 21.06 rounded to the nearest tenths. The hundredths place is bigger than 5 or bigger than 4. 5 or larger, and so we round the 0 up to a 1, so it's 21.1. So now we found x. And so now we can find the area. So the area, let's do it over here, the area of the big triangle is equal to base times height divided by 2. Base times height divided by 2. And that is equal to base, which is x, which is 21.1, 21.1 times height, which is 11.5, divided by 2. So we just have to take this product and divide by 2. And we can do that. 21.1 times 11.5. Okay, let's multiply it out. 1 times 5 is 5. 1 times 5 is 5. 2 times 5 is 10. 1 times 1 is 1. 1 times 1 is 1. 2 times 1 is 2. Okay, and then 1 times 1 is 1. 1 times 1 is 1. 2 times 1 is 2. Stack add. 5, 6, 2. 1 plus 2 is 3. 3 plus 1 is 4. 2. Okay, and then 2 decimals over. 242.65. It says round intermediate values. Okay, so to the tenths place. So that's, to me, it looks like 242.7. So 242.7, 242.7 divided by 2 will give us the area. Okay, so 2 goes into 2 one time, 2 goes into 4 two times, 2 goes into 1 two times, or one time. Point, 2 goes into 7 3 times, and then you'll end up with 1 remainder 5, so it's going to be 121.35. And rounded to the nearest tenth, that equals 121.4. So the area of the big triangle is equal to 121.4 units squared, and that's the area of the big triangle. And so now we just have to combine the areas. So now we know this right here is 121.4 units squared, and this right here is 46 units squared. So the combined areas is just 121. So this is combined area, 121.4, because I guess we rounded to some intermediate value. Yeah, 121.4 plus 46. Let's see what that adds up to. 4 plus 0 is 4. 6 plus 1 is 7. 2 plus 4 is 6. 1 plus 0 is 1. 167.4 units squared. And there again, look. Now see, I feel like we did everything right. I mean, I don't know what's wrong. But look at the answer choices. You got 167.4 is what we calculated. And this is the closest thing to it. So, you know, again, math works, right? But somewhere in here, rounding to the nearest tenth, we got something didn't go right. Literally we're off by a tenth. But it's so close that it's obviously A, right? So that is the 20 question test. And, you know, it took a lot longer to explain out loud than it would have in the testing environment. But you work on these problems and you will get faster and faster at them. Just as a final recap on this cumulative exam, this was a tour of more advanced mathematics. So this was a tour of geometry and even beyond, a little bit beyond geometry. Not much. I mean, most of this stuff is just, I mean, these problems here come from the end of geometry, and these problems here come from Algebra 2. I mean, I simplified them to make them suitable for Algebra 1 or geometry. These problems right here, these inverse functions, I mean, it's taught in Algebra 2, but it was easy, you know? And I feel like it's appropriate to teach it now because we know how to solve systems of linear equations and we know how to graph functions. So why not just go ahead and learn that inverse thing, you know, swap the x and the y and solve for y. And then, yeah, this was fun. I think this was pretty easy, right? It's one of those Algebra 2 concepts that terrifies people, but when you guys see it, this is the beauty of doing this. When you guys see this, you will no longer be terrified. And you have these videos to look back on. And you can always come ask me for help. Some simple geometry problems. This is just the bare minimum of what you'll be doing. And then we took a time travel back to 7th and 8th grade, or whenever it was that you did this, 7th grade. You do these geometry problems, finding volumes. That was so much fun. That was the most fun part of the test for me. I don't know about you. I really enjoyed drawing. And then I got to tell you, these were fun. So these were fun because we had to prime factor the number under the radicand. And here, this was to me the most interesting because we had to use many, many steps to solve the problems. I mean, I just love it when we just fill up pages with mathematics. Look at that. Just look at all those calculations. And the amazing thing is that we relied only to a minimum degree on the calculator. You know, we had to take square roots and we did check our numbers, but not until the very end. Not until the very, very end did we do that. So look at all these pages. It's just pages and pages and pages. It was somewhat upsetting to me to see that people were turning in the tests and scoring very highly on those tests with almost no work shown. I mean, because look, I'm your teacher and I'm showing all the work. And so you see that there are, I mean, how many pages are there of work right here? How many pages are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if you count the back of that, 11 pages, 10 or 11 pages worth of work. And, you know, what I got turned into me was mostly maybe a page of work shown. And the question I had when I was grading those tests was, how is it possible that, you know, without using a calculator, you were able to find all the answers without doing any work? So, you know, as you're doing these corrections, please understand that I know it's not easy to sit and do math for 3.5 hours, and I know that because I just did it. I just sat here uninterrupted, you know, on a Friday night after school, after a whole long week of work. You know, it's 10 o'clock at night right now, and I just recorded this. So I definitely understand exactly how it feels to sit stationary in a chair and do 3.5 hours worth of mathematics, because I just did it. There's no editing in this video. So I'll bring the video to a close with a final thank you to my students for this year. You guys, I hope you learned something. You know, I remember when the principal hired me for this job originally, couple years ago, for teaching in this district. He said, can you please just teach the kids something? And it was a different subject back then. It was government and economics. And so I kind of took that to heart. I mean, he didn't give me a curriculum map and a lesson plan and say, here, I want you to teach these things. He just said, please, he was pleading with me, please go teach the kids, please teach the children something. And so I tried to teach the children something in government and economics. But then when there was that staffing issue and I became a math teacher, you know, the current principal asked me kind of something similar. Do you think you can please go in there and try to teach those kids something? And so all year I've kind of kept that in mind. And if you're somewhat angry or concerned that at the very end of the year I decided to push harder than ever throughout the year, it's because I really do respect you guys. And having sat here and the pain in my back from sitting for 3.5 hours doing this video on a Friday night comes out of respect for you, not hatred. I mean, I respect you, and so I'm trying my best to demonstrate that respect by teaching you, by doing. You know, don't tell me, show me. You know how people say that? Don't tell me what you're going to do, show me what you're going to do. I wanted to show you how to do this, so when you move into your geometry classes, and some of you, people say, well, how come you introduced Algebra 2 at the end of Algebra 1? Because, well, I have students, some of you watching this will be taking both geometry and Algebra 2 next year. So I wanted you to see what's coming. I wanted you to see it and not feel terrified that you can't do it because you just did, right? This cumulative exam is entirely composed of geometry and Algebra 2 problems. So if you're taking geometry and Algebra 2 next year and you watch this video and you did all these 10 pages worth of work, then you're ready. You're ready to rock and roll. Just combine that with what you know from Algebra 1 and 7th and 8th grade math, but mostly Algebra 1, and you'll do just fine. Okay, well, I'm going to wrap it up here and just thank you guys very much again. It's been a great year. As I told my boss, principal, I said, this has been the most challenging year of my working life as a teacher, and it's also been the most rewarding. So most challenging and most rewarding. And I hope for you, if you've been engaged in this class and you've been doing all this work, I hope for you it has also been the most challenging class you've ever taken, and the most rewarding. So you might have taken harder classes, but were they as rewarding? I really hope this was the most challenging and the most rewarding class you've taken. So as a final note, what I would like you to write on your test is I'd like you to write a one-sentence response to this question. And the question is, was this class the most challenging and the most rewarding class you've ever taken? In other words, dollar for dollar, did you get your money's worth in this class? I mean, answer this question. Was it worth it? Did you learn enough in this class? Did I challenge you enough in this class that you feel like your investment of time and energy was paid off? And the reason I'm asking that question is I really want to know, did I do a good job teaching you? And if I did a good job teaching you, it's like a trainer in the gym, okay? If you leave the gym breathing normally, laughing with no muscle strain at all, then maybe the gym trainer didn't do a good job, right? You should kind of leave the place, you know, stronger than you were when you came in, but also really, really torn down and exhausted. And so that's what I'm looking for. I'm looking for that workout. Um, I want to know, did it challenge you, and was it rewarding? I know that you might not love math, but did you feel like you learned math? And I wish you guys would please, on your tests before you turn them in on Monday, just write me a little blurb on the back explaining, the degree to which you found this class rewarding. Maybe you could just include a page with a note if you wanted to, or a couple of sentences, or even one sentence. Did you find this class rewarding? Did it feel like a mental workout for your brain every day? Did I bring it enough to keep you guys challenged? Do you feel prepared for next year? Okay. Um, if you could please answer those questions. And also, is there anything I can do to improve being a better teacher for future kids? Help your people that are coming up from 8th grade. If you guys could let me know the answer to those questions, I would really appreciate it. And feel free, if you want, to leave a comment with the answer to those questions. I would really appreciate it. Or you can write it on your test if you don't want to post publicly. But with that, I'll close it up. And thank you guys for what was, for me, the best year working with you. Thank you so much.